All right, ladies and gentlemen, in the last video we talked about finding the magnitude of a vector when we were given the two sort of pieces of it. And I should have mentioned before, we call those pieces components. They are parts of the whole. And when we put those components together, we get what we call a resultant vector. So if we've got the two pieces like this, these are both components. Run out of space. And if we took and put those together into one, that would be called a resultant. Just a little extra information there. So we talked about finding the length of that resultant, the magnitude of that vector. Here now we want to talk about finding the direction of that vector, and we do that by taking the angle that this triangle makes. This little Greek letter, the circle with the line through it, is a Greek letter theta, and that represents our angle. So before we can really do this, we need to get some sort of definitions out of the way. Hopefully most of this is stuff you have seen before, but if not, I want to make sure that you have at least now. So when we talk about any right triangle, we can label the three sides differently with different names. The hypotenuse is always the longest side, right here. It is always on the other side of the triangle from the right angle. If we have a right angle, the side that does not come in contact with that angle, it's not part of that angle, is our hypotenuse. Then we have to pick which angle we want to talk about for our purposes. Most of the time that will be this angle right here. We'll set up most of our triangles this way. It's whichever one you put the theta in. The opposite side from that angle, what we call the opposite, is the side that does not touch the angle that we're worried about. This whole side right here, none of that side comes in contact with our theta. The adjacent side, right here, does come in contact. It's adjacent, it's right next to. But just be careful about which one is the adjacent side and which one is the hypotenuse. So hopefully you've seen all of that before. This diagram can hopefully help you as well. We are also going to need some trig functions, some definitions of sine, cosine, and tangent. The sine of an angle is equal to the length of the opposite side divided by the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. One of the common ways to remember this is SOHCAHTOA, S-O-H. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Get used to, we will use these a lot. You will have them memorized by the end. But remember SOHCAHTOA, that is typically the easiest way to keep all of those straight. So let's go back to one of the previous samples we did from the last video. We had this 100 meters and 200 meters, and when we found the resultant length, we formed this triangle that had 223.6. So now we've got this guy. So this is really our resultant. This is what we were worried about. But remember, for any vector, we need a magnitude, which we already found, but we also want the direction. So the direction here is theta. I tend to make it with the x-axis. Whatever angle is being made with the x-axis, that's the one I want. So I have some options. I can use whichever of those trig functions I want to find this angle. So just because it's first, I'm going to use the sine of the angle is equal to the opposite over the hypotenuse. Then it's just a matter of picking out which variables I have. My opposite side is this green side here. It's not in contact at all with the angle, so 200 goes in for opposite. My hypotenuse is the side that is across from my right angle. My right angle is right here. So this red side that was blue before, that resultant is my hypotenuse, 223.6. That equals the sine of the angle. So if I take 200 divided by 223.6, I get 0.894, but that still equals the sine of the angle. I have not found my angle yet. A lot of people tend to stop here, but we need to take one more step. We have on our graphing calculators, or on most of the scientific calculators, a inverse sine, inverse cosine, and inverse tangent. If you have a TI calculator, which is what I have, if you take and you hit, right there is sine, and if I do 50 maybe, the sine of 50 is some value. But if I want to do the inverse sine, which is what I want to do, I hit second and then sine. So I'm going to go back here. In order to just get my angle by itself, think of this sine as kind of like a square on that angle. It's certainly not the same thing, but I have to do something to undo that square. I have to do something to undo that sine. So to do that, I take the inverse sine of both sides. Just like if you were going to get rid of a squared, you would do a square root to both sides. So these sines, the sine and the inverse sine, cancel out, leaving me just theta, just my angle, is the sine -1, the inverse sine of 0.894. One thing I also want to make clear as well, we do have to be in degree mode on our calculator. So if you hit mode, scroll down to degree, radian, it might be in, click over to degree and hit enter. That will get you the correct answers. If you don't, it will come out wrong. So sine to the negative first of 0.894. Get back to it. So 0.894. Hit enter. I have an angle of 63.4 degrees. So theta equals 63.4 degrees. And I can double check this. If I have an angle that is bigger than 45, this opposite side here should be bigger than the adjacent, which it is. So I've got my angle as well. So now I've got both a magnitude and a direction of my vector. I could have done this another way as well. Because I have all these sides, sometimes I prefer to take whichever sides the problem gave me. So here that would have been the adjacent and the opposite, and use those. That way I know I'm getting accurate information as I plug in. So if I take the tangent of the angle is equal to the opposite, which was 200, over the adjacent. If I take the inverse tangent of both sides, I end up with the inverse tangent of 200 over 100. And I don't necessarily have to do that fraction out beforehand. I can say second tangent to get the inverse tangent of 200 divided by 100. And that will come out correct as well. It comes out slightly different. That is only due to rounding. Either of those answers, 63.4, whatever it came out to here. So both of them are rounding up or down to 63.4. Again, they do come out a little different. That will not be an issue on the test. So if we are getting an angle, we actually have to do the inverse tangent or the inverse sine or the inverse cosine. When we're trying to find a particular side, we're going to do the opposite. We'll actually use the regular sine, cosine, and tangent, and that will be in the next video.